this video, we're going to look at the difference between linear and exponential models and hopefully help you pick out some ways to tell the difference, when to apply which one. So in the first one, this first example, we're going to look at the linear growth or decay model. The key here is there's a constant rate of change, and it's going to be in a unit related to your original unit. So it's the same amount being added or subtracted over each interval of time. Our example, your salary this year was $50,000. Your employer agrees to give you a raise of $750 per year for the next 10 years. Here's the key. Your original amount was $50,000. It's in dollars. The change that's happening is $750 per year. So the change is also in dollars. That is the same amount that you're going to get every year. Every year you will get $750. That is a linear model. Before we write the equation, let's contrast that with the second one. The second example is your salary this year was $50,000. So same base, right? Your employer agrees to give you a raise of 1.5% per year for the next 10 years. So your raise is going to be a percentage. That is the key, that the change is a percent change. It's not a dollar amount. So it's not a set dollar amount. It's a percentage of your salary each year. That means your raise is going to change each year because your salary increases each year. So that's how you tell the difference. If the increase or decrease is a percentage, a percent change, that is an exponential model. If your increase or decrease is a set amount, in this case a dollar amount, that is an indication that you have a linear model. So for the first one, let's write an equation that represents the situation. So our linear model looks like this. F of x equals mx plus b. So the m is your variable amount, or the amount that's changing. The b is your initial amount. So the m is the variable amount. You can think of it as the growth factor. Well, it's not a factor. The growth rate. Okay. And then the b is your initial amount. Another way to think of it is the m is the variable rate and the b is the fixed rate. So if we look at it that way, we will have f of x equals, it's growing by $750 per year, and we started with $50,000. So that's the equation that represents this situation. Use the equation to determine your salary after 9 years. So $750 per year, so 750x means that x represents the number of years. So I'm going to plug in 9 for x. So f of 9 is equal to 750 times 9 plus 50,000. So 750 times 9 is 6750. And then adding that to 50,000, I will get 56,750. So that is my salary after 9 years. So let's compare that to this one. So we want to write an equation that represents this situation. You need to remember that your exponential model, let's use function notation, is f of x equals a times b to the x. Remember that a is your initial amount and b is your growth factor. So your growth factor or decay factor. Remember that if it's a growth factor, it's 1 plus your rate, whatever you're growing at. If it's a decay factor, it would be 1 minus r. So our equation is f of x equals, our initial amount is 50,000. Our growth factor, so it's growing at a rate of 1.5%. So as a decimal, that's 0.015. So adding 1 to that, so we would get 1.015 raised to the x. So there's our equation for this situation. And then the second part is the same. Let's find out what your salary would be after 9 years of getting this 1.5% raise every year. So when I entered this in my calculator, I got $57,169.50. So after 9 years, that would be my salary if I received a 1.5% raise per year.